The rectifiers. So this topic will be in our fifth chapter. And first of all, we need to know about the concept of a rectifier. Okay, so rectifier is nothing but an electronic device which converts AC signal to DC signal, which will be used in many digital applications as well as our home appliances. So now in this rectifier, there are different kinds of rectifiers available. So half-wave rectifiers, full-wave rectifiers, and bridge rectifiers. So now today we are going to discuss and experimentally we can prove the half-wave rectifier. So what will be the input given to the rectifier and how we are getting the output at the CR. Okay. In this half-wave rectifier setup, we'll be having the components like transformer. We need a diode and resistors, connecting wires and probe. So these are the components required to do this experiment. And regarding the connections, so first we need to connect the connecting probe in the CRO. Okay, so and that will be given to the breadboard. So okay, in the breadboard, the diode will be connected and in series with the diode, the resistor will be connected, and the resistor terminal, other end of the resistor terminal will be grounded. Okay, and then the positive terminal of the CRO will be given to the positive terminal of the diode, and the negative terminal of the CR will be given to the ground. Okay, so this is the very simple setup. And in transformer connection, in transformer we are having 3 wires. Okay, so this is a 909 volt transformer. Okay, so the 9 is positive, 0 is negative, again 9 is positive. So in this half-wave rectifier, we are going to use only 2 terminals. One is positive 9 volt and negative 0 volt. So in this, positive 9 volt will be connected to the positive terminal of the diode. Okay, and then in negative terminal of the diode, it will be the output. So if we are connecting the positive terminal of the probe to the input, we can see the input waveforms. So you can see the input waveform here. So now I connected the CRO at the positive terminal. So we will be getting the sine wave. So this is the input. So here I wrote single phase 50 Hz AC supply. So this is nothing but single phase 50 Hz AC supply. So this is supply coming in our main. So this is what we are going to convert into DC by using the diode. Okay. And this signal will be converted in the transformer. What is function of transformer is, here we are using step down transformer. Okay, so the 909 is nothing but step down transformer. So it will convert the 230 volt AC signal into 9 volt. That is also AC signal only. Okay, but it is 9 volt. And that particular 9 volt will be given to the positive terminal of the diode. So, okay, so that 9 volt will be processed in the diode. Okay, and then after processing, the output will be at the negative terminal of the diode. So the same connecting probe, now I am going to connect it in the negative end of the diode. Now we can see the rectification. So initially we will be having a full sine wave, and now we are getting the positive cycle, that is alternate positive cycles. Okay, one positive, if the diode is on, one positive cycle will be there, and if the diode is off, the negative cycle will be getting eliminated, and another next cycle, another positive cycle will be available, and another next negative cycle will be getting eliminated. So this positive negative cycle will be depends on the on and off condition of the diode. If the diode is in on condition, we will get a off cycle. If the diode will be in off condition, the negative off cycle will be getting eliminated. So this will be continuously, it will be going. And now let us come to the concept of rectifiers. So here we are converting the AC to DC signal, but here in this rectifier, the amount of AC signal converted to DC signal will be 40% only. Okay, the remaining percentage of that we can call this unwanted signals. Okay, our actual output is what? DC, but unwanted AC components present in the DC output. So that we can call that as ripples. Okay, the ripples nothing but the unwanted signal. Okay, so for improving the performance of this circuit, we can also have full wave rectifier. In full wave rectifier, we will be using 2 diodes. Okay, so one is connected at the one positive of the transformer, and for the another diode will be having another positive, another 9 volt there in the transformer. That 9 volt will be given to the second diode. Okay, so similarly, the same kind of output will be arriving at the output, but the difference is will be getting continuous half cycles. Here also negative cycles will be getting eliminated because we are using two diodes. Okay, so at the first cycle D1 is on, D2 is off, and second cycle D2 is on, D1 is off. So this process is continuously getting created. So we will be getting, instead of alternate positive cycles in full wave rectifier, we will be getting continuous positive half cycles. Okay. Now here the efficiency related to full wave rectifier will be around 81 percentage. Okay, because we are using two diodes here, and we are also upgrading the rectifiers. So initially we used a half a rectifier where we get a very low amount of output at the CRO, and if we are connecting the two diodes, the output is doubled. Okay, already told that in half rectifier we will be getting around only 40%. If you are using full rectifier, it is around 80%, which means 80% of the AC signals are converted to DC signal. So that's the meaning of that 80% and 40%. Okay, this only 20% of the AC signals will be present in the DC output. So comparing to the half rectifier, we will be getting more efficiency in full wave rectifiers. Okay, and these kind of rectifiers having a wide variety of applications. Okay, that's it. Thank you.